Supernode analysis. Suppose any of the branch in the network has a voltage source, then it is slightly difficult to apply nodal analysis. One way to overcome this difficulty is to apply supernode technique. In this method, the two adjacent nodes that are connected by voltage source are reduced to a single node, and then equations are formed by applying KCL law as usual. So this is our circuit. We have the node 1 having the voltage V1, node 2 having the voltage V2, and we have node 3 having the voltage V3. A fourth node taken as reference node, we are having the voltage source between V2 and V3 at the node 1. So when you redraw that, I R1 is I R2. Then applying the KCL, we'll get I equals to IR1 plus IR2. Then I is equals to IR1 is V1 by R1 plus V1 minus V2 by R2. Now, if you write this 1 by R1 plus 1 by R2 of V1 minus 1 by R2 of V2. This is the question number 1. Up to here, there is no problem since there is no voltage source in between these two. Now, due to the presence of Vx between V2 and V3 and use the supernode technique, accordingly, we combine the nodes 2 and 3 at supernode. Applying KCL, V2 minus V1 by R2 is R2 plus V2 by R3 plus V3 minus V1 by R4 plus V3 by R5 equals to 0. Now rearranging this 1 by R2 of V1 plus V2 of 1 by R2 plus 1 by R3 plus V3 of 1 by R4 plus 1 by R5 equals to Vy by R4, which is the equation number 2. Between node 2 and node 3, we have the equation that V2 minus V3 equals to Vx. As V2 is positive and V3 is negative, I'm taken like this. Then this is our equation number 3. So by solving equation 1, 2, 3, we can find unknown voltages. This is our given network having the node 1, 2 and 3, and this is grounded node. Then the voltage across node 1 is V1, at node 2 V2, at node 3 V3, and at node 2 and 3 there is a voltage source. So supernode analysis is applied to this network at node 1. So draw this. We always assume that voltage at node is higher potential. So this is the directions of the currents when the current direction is not given. Applying KCL, we can write that V1 is at higher potential minus 40, since it is in the opposite direction of current flow. So minus 40, and it is connected to V3. So minus V3 divided by the total resistance 4 ohms plus second one, that is V1 minus V2 divided by 6 ohms. The current is here is coming, but our assumed direction is away from the node. So I'm taking this as a minus 3 amps, and this one is also coming to the node, but my assumed current direction is away from the node. So 5 amps equals to 0. All this you are going to get 0.42 V1 minus 0.167 V2 minus 0.25 V3 equals to 18. Number 1 at node 2 and 3, since it is a super node. Applying KCL for this, V2 minus V1, 6 ohms here, divided by 6 ohms plus 5 amps is going away from the node 2, plus V2 by 3 plus V3 by 5 plus V3, this 40 is in the same direction, that is going away from the V3. So it is in the same direction of current. So plus 40 minus V1 divided by 4 equals to 0. When you simplify this, you are going to get minus 0.42 V1 plus 0.5 V2 plus 0.45 V3 equals to minus 15. Let this be equation number 2. Now, between the supernode V2 and V3 minus V2 equals to 20 volts. This is equation number 3. Solving these three equations, you are going to get the voltages V1 equals to 52.89 volts and V2 equals to minus 1.89 volts and V3 equals to 18.11 volt.